Hello, ladies and gentlemen, and welcome back. We're continuing our look at the 2006 Fermat contest, and we're on the very first of the challenging questions, the 5 questions at the end of the contest, Part C. We're on question number 21. So I would once again like to encourage you to try these questions before watching the video. Pause, try them out if you haven't already. I'm going to assume you've done that. Let's take a look at 21. For how many integers n, with n between 2 and 80 inclusive, is n minus 1, n plus 1, all multiplied together over 8, equal to an integer? Okay. So, how do we get the top expression divided by 8 equal to an integer? Well, I've seen questions like this in the past, and notice, we'll motivate it a little better by trying some numbers out. Does 2 work? Now we'll just work that out. So 1 times 2 times 3 over 8, that's 6 over 8. That's not going to work. How about 3? That's 2 times 3 times 4 all over 8. That's going to be 24 over 8. And yeah, that works. How about 4? Well, we'll get 4 times 5 times 6. Oh, sorry, no, that's if we had 5. We'll have 3 times 4 times 5. All over 8, and that's going to be 60 over 8. These numbers are getting much bigger, and that's not going to work. 60 has a factor of 4, but not a factor of 8. How about 5? I keep putting my n as my first number. No, bad root beer. There we go. So that'll be 24 times 5, 180. Over 8 is going to be 15. So that works. How about 6? Okay. So that'd be 5 times 6 times 7. We can start to see that, maybe the even numbers aren't working out because, look, we've got 2 odd numbers on either side. They're not going to contribute any factors of 2. And remember, 8 is just 2 times 2 times 2. So really, we need to have 3 factors of 2 somewhere on the top. They don't have to all be concentrated on one number. Here are 2 factors of 2 and then 1 factor of 2. That's what makes this one work. But the even numbers, it's really not going to work out. At least not all the time. So that's an observation we can make. So why not? Because most even numbers will just have a factor of 2 or a factor of 4. Only if n is divisible by 8 will an even n work. Give us an integer, I mean. Okay? Only if all the factors of 2 that we need are in that even number will this work, because you get 2 odd numbers on either side. So n equals 6, that's not going to work out, but n equals 8, well, surely that one will work out. The 8's cancel, and we get 63, an integer. So we can start counting up these. How many of these even numbers will work? We get 8, 16, all the way up to 80. There's 10 of those. 8 times 1, 8 times 2, all the way up to 8 times 10. So 10 of these will work. And you'll notice that 10 is one of the answers. But already we've seen other ones that will work, other ones that aren't even numbers. Don't get swept up in counting this one case and forget that n equals 3 works. N equals 5 works. How about n equals 7? It's going to work as well. 6 times 7 times 8. Not only because there's an 8 there, but it's because we got 2 even numbers on either side. And we're going to get 42 here. It looks like odd and always work. Okay. Now 2 to 80. If you spent maybe 5 minutes working out with all the odd numbers, you could probably convince yourself that, yeah, it's going to work out. You could even count them up. And yes, every odd number will work. Let's talk about why. Okay? Any odd number, n, is surrounded by two even numbers. So n minus 1 and n plus 1 are both even. 2 divides them. So they each automatically contribute a factor of 2 to our product. And to divide by 8, we need 1, 2, 3 factors of 2. Well, there's 2 of them already. Okay? So how do we know we're always going to get a guaranteed extra factor of 2? Well, think about even numbers. Let's ignore the odd numbers. Let's ignore n for a moment. Think about even numbers. 2, 4, 6, 8, 10. What's going on here is that each of these numbers, one of them is just divisible by 2, the next one's divisible by 4. Then just divisible by 2, then has a factor of 4. 2 has a factor of 4. Just divisible by 2 has a factor of 4. Why is this working out, you might ask? And the reason is, let n minus 1 be 2k. We know it's divisible by 2. We know it's n minus 1 is even. Now, either if k is odd, then k plus 1 is even. So we could write k plus 1 is 2m. But n plus 1 is n minus 1 plus 2, which is 2k plus 2, which is 2 times k plus 1, which is going to be 2 times 2m, which is 4m. So this has a factor of 4, this one has a factor of 2, combined they have a factor of 8. If instead k is even, then k plus 1 is odd, but I can write k is 2m, so n minus 1 is going to be 4m, m plus 1 is just going to be 2k plus 1, but again we get a factor of 8. So the product of any two consecutive even numbers is always a multiple of 8. So any odd n will give an integer. So we already have 10 even numbers that will work. 8, 16, 24, 32. Those are separate and distinct from the odd numbers that will work. And it turns out all odd numbers in our range will work. 3, 5, 7, all the way up to 79. So we just need to count those. So the number of odd numbers is going to be 80 minus 2. And half of them are odd integers, which is 2. And you might say, well, do we need to add 1 or subtract 1? Because if we started with odd numbers, we'd probably have to add 1 in there. So for example, the number of odds between 3 and 5 inclusive is going to be 2, which would not be 5 minus 3 over 2. You'd have to add 1. But we can double check that this formula really does work. How many odds are between 6 and 2? It's just 3 and 5. 6 minus 2 is 4 over 2. Yeah, it's going to work out. So this is 78 over 2, which is 39, plus the 10 others that we know will work. And we're going to get 49, which I think was C. No, I was wrong. It's not C, it's E. But there we go. That finishes off question number 21 rather nicely. We understand it fully. You don't have to prove that you always get the 8. Just if you're based off a hunch, you guess, well, all the odd numbers seem to be working, I'm not going to waste too much time. You certainly move on. Pattern recognition is a great strength for doing these Pascal-Cayley-Fermat questions quickly. And we want to be quick because we still have 4 more questions to go here. And we'll take a look at question number 20 in the next video. Thank you so much for watching. I'll see you next time.